So friends, let us start with our discussion. So I have shared the screen. Is it visible to you?
Yes, sir.
Yes, sir.
Yeah. Okay, fine. So we have seen that in case of modern voltage, modern drives using the control converters or the power electronics. So in modern DC drives, they are containing this stop start. Along with this stop start, one more facility is added in that. That is the field failure protection. What do you mean by field failure protection, and what is the necessity of it? If in the previous equation we have seen that the speed is directly proportional to VA, that is speed omega is equal to VA minus IARA divided by KA into phi, and phi is proportional to IF. So KA into IF. That means speed is directly proportional to VA, and it is inversely proportional to IF, that is field current. Now if field current or field circuit fails, that means there will be an open circuit. So that means field current value IF will become equal to 0. As IF is becoming 0, the speed is inversely proportional to IF. So if IF is going to 0 value, then what will be speed? Speed will become infinite. So as speed is becoming infinite, it may damage mechanically the motor. So that's why, in order to avoid that, field failure technique is means field failure facility is provided along with this modern control converters. So what is that? A very simple circuit is there in which a relay is used, and that coil of relay, it is placed in the field circuit, so that whenever field current is flowing, that is flowing through that coil of the relay. So that is magnetized and it is energized, and the relay is connected, that NC and NO contacts, they are connected in the armature circuitry. So whenever field current breaks, at that time the relay coil, the current flowing through that relay coil will reduce to 0, and the relay will change its contact. Means it will disconnect the armature from the supply, so that your field failure means field failure will be taken care. And these are the points which I was interested to discuss with you for theoretical. Now for practical purpose, this is the procedure, and procedure is very simple. You have to connect the circuit as shown in figure. So that figure is shown to you, and you have to make the connections as per that, and you have to ensure that the field rheostat is at its minimum position and armature rheostat is at its maximum position. Why? Because armature rheostat at its maximum position, so that armature current should be minimum, and the field rheostat is at minimum position, so that field current is at its maximum position. Means field current should be maximum and armature current should be minimum, because speed is directly proportional to armature current and speed is inversely proportional to field current. Then switch on the supply, vary the voltage across armature using armature rheostat, and keep the field current constant at a constant value. Note down the readings of armature voltage and speed. So this is half part of experiment is over. Then vary the current through field winding using field rheostat and keep the armature voltage to a constant value. So we are performing now second experiment, second part of that, that is field weakening method. So we have kept field armature voltage to a constant value, and we have started reducing the field current. and then note down the readings of field current and speed, and plot the graph of armature voltage versus speed and speed versus field current. So these two graphs you have to plot. So you will get these two observation tables. One is field current in amperes, so that reading, and speed in RPM. This is one part which is field weakening method, and this is the armature control voltage method, armature voltage control method, in which field current you have to keep constant at a particular value and vary the voltage, and you will get a variable speed. Note down the readings and plot the graph. Okay, so for implementation on virtual lab, I have shown you, given you two links. This is for field control method or flux control method, and this is for armature voltage control method. This one link is from IIT Bombay, and this is also from IIT Bombay. So these two links for these two practicals are provided from IIT Bombay virtual lab, and these two links I have provided it for you from IIT Roorkee. So you can click on either of these and you can start performing the practical. So for performing the practical on visual lab, if you will go on that particular experiment, you will find there are steps for performing the practical on virtual lab. You will find these seven items which you can click. One is aim, theory, pre-test, procedure, simulation, post-test, and references. And one more link is there for feedback. So first aim, if you will click on this, you will find what is the aim of the experiment. Theory, related theory you can get. Then pre-test, what is your prior knowledge that they want to test. So you can appear for pre-test, you can test your own knowledge before performing the experiment. Then from procedure, you can read the procedure. What is the procedure to perform the practical? What are the connections, circuit connections are there? You can go through that, and then you can go for simulation, in which you can follow the procedure which is mentioned in that procedure, and you can simulate the result, and you can find the that truth table, observation table you can fill, you can prepare a graph. The entire thing is ready-made. You can plot the graph even on that, and then you can give post-test. So after performing the practical, what knowledge updations you did, so that is post-test, and the references you can get. So when you are going in that procedure, simulation setup, you will find such setup in that practical. You will find these meters, these rheostats, this is the DC motor, this is the front view, and this some your MCB and all for applying the supply. Then in procedure part, you can get the connection diagram. So this type of connection diagram is given to you. That connection diagram, you make a note of this for armature voltage control, and same if you go for field control or flux control, you will get circuit diagram for this connection diagram. You can refer this connection diagram. You can perform the practical. So I have performed it for you, and on this IIT Roorkee virtual lab, I have made these connections, and I have noted these readings of voltage and speed, and then plotted the graph. So this is the entire practical for the half part, that is one armature control and another for field control. Now let us see how to perform that practical. So I'll share another screen. I'll stop sharing this screen, and I'll share the screen which is of the lab. We'll directly move to that. Yes. So I have shared another screen. Is it visible to you now? speed control of DC motor by armature resistance control. Is it visible to you? Yes, Avi?
Sir.
Is it visible? Yes, anybody?
Yes, sir.
Okay. Then I'll explain how to perform this. So aim is there. You can click on this left hand side, that menus are there. So aim is there. So I have clicked on aim. So it is available. Theory, you can click on that theory, so that theory will be available to you. Then pre-test, you can go for pre-test. Then procedure is there. You can go for procedure. In procedure, this connection diagram is there, and what procedure you have to follow, it is mentioned. You can go through this procedure, and then you can go for simulation. So if you will go for simulation, you will find this simulation. Click here to go to the simulation page. So I will go to simulation page. Whenever I will go to simulation page, this entire front panel will be available. So on this front panel, MCB is there. This 3-point starter is there. MCB is to turn on the supply. Then the starter is there. Voltmeter, ammeter is there. Speedometer is there. These rheostats are there to vary the resistances. One is for field resistance, another is for armature resistance. Then this is the motor, DC shunt motor, and its rotor. That is the front view, so that you can feel whether the motor is rotating or not. And then here observation table is there to create the graph. So serial number, voltage and speed. And here you can create the graph. And ultimately you can take print of the entire connection diagram. Okay. So we will start making connection. So I hope you have remembered the connection. And if not, you can go to this instruction. You can click on this instruction. So you will find the procedure. The following procedure is to be followed for simulation. Make the proper connection as per instruction. First of all, connect the positive terminal of MCB to the negative terminal of voltmeter and this. So you can go through this procedure and you can make the connections. So I am having the diagram, connection diagram with me. So I will make the connections. So first of all, I will take this negative of MCB and I will connect it to this L. Then this positive of MCB, I will connect to one terminal of voltmeter. Then I will take it again, I will connect it to one of the armature and one of the field windings. So these I have connected. Then I want to connect this field resistance rheostat. So that I will connect it in this field winding, series with field winding. Another terminal, I want an ammeter in series with this so that I can measure the current flowing through this. So I have connected it. Then I will connect this armature rheostat. So armature rheostat, I will connect it to one of this terminal. Then another terminal, I will connect it to the supply voltage, which I will get it from this point. Then I want to connect a voltmeter for this. So I will connect a voltmeter here, and then I want this field to armature ammeter. So I have connected it. Now, whether the connection is complete or not, so that I can check. So I'll go on this second green button, check. I'll apply check. So wrong connection is mentioned. That means I have missed something. Okay. So I have purposely missed something. So now I'll make the connections, proper connections. I have made these connections for field control. I have observed that after checking, it is giving me that correct connection, proceed to take readings. Then I'll click on OK. So I have checked this connections. Now what is the method? First of all, I have to keep some armature voltage, and then I have to reduce this value of field current. Okay. Okay. So I have not turned this on, so I'll turn it on. MCB I'll turn on first. After checking the connections, I have to turn on this MCB. Once MCB is turned on, I'll get some readings on this meters. So I have got the readings of voltmeter, and I'll change this. So you will find that the motor is rotating and the speed is 2500. Speedometer is reading. This something ammeter is reading and voltmeter is reading. So what is that reading? That whatever reading is there, you can add it in a table. So you click here on add to table. So automatically here the table will be generated. Current in ampere is written as 0.1 and speed is 2500. So 0.1 ampere is the current and speedometer is showing 2500. So these readings are noted. Then I'll increase the field current. So I have increased field current. So this is second reading I have got. Then I'll add it to table. So current value is 0.2 ampere and speed is 2340. You can see the reading of speedometer. It is 2340. Then I'll increase again further this rheostat value, field resistance. So if you will increase the value of this field, it is third reading. Okay. Then the value of current meter is showing, speedometer is showing 2100. I'll add it to table, and this procedure I'll repeat at least for 6 more readings so that I'll be able to plot the graph. So minimum 6 readings are required for plotting the graph. So I'll take another reading, 5th reading, add it to table, then 6th reading, add it to table, okay, and add it to table. If you want further reading, you can take 7th reading. 7th reading is there. I'll add it to table. I'll take one more reading, let us say, and I'll add it to table. So current value, now you can see the table. You can see the table, observation table, armature, field current is increasing from 0.1, 0.2, 0.3 to 0.8, and speed is reducing from 2500 to 1400. So whenever the field current was 0.8 ampere, at that time the motor was rotating with 1400 RPM. And as I have started weakening the field current, that means I have started reducing the field current, then the value of speed has started increasing, and it has gone to 2500. Then after observation table, above this you can see plot graph. So I'll press this, so graph will be plotted of speed and current. So you can find the current value, it is 0.1, so speed is 25, 100, as current value is 0.2, speed is 2340, and so on and so forth. And the graph is plotted. Then you can go on this print so that the entire screen means circuit diagram and your graph will be available on this. You can save it as a PDF or so you can save it to a particular location so that the entire circuit diagram, connections, observation table and this graph will be available to you. So I hope you have understood the practical, how to perform it. And the same practical I have already performed for you, and that I'll change the screen. So that is already there on this. So you can find that. This. So this is for field current, this is for field current weakening method, readings, graph, and this. Okay. And this is for the another, that is armature voltage. So I think you can perform this experiment on your own. Take the printout of this graph and then you have to submit it. Okay. And if possible, later on we'll perform it in the laboratory of our institute. So I hope you understood the things. I'll stop recording first and then we'll discuss.